Welcome back to Einstein's Mechanics. In this episode, we are going to solve second example on the row operation, finding the inverse of a 3 by 3 matrix. So straight away, let's look at this. We have a matrix A in the form 1, 2, negative 1, negative 2, 0, and 1, and we have 1, negative 1, 0. So we have to find A inverse. Are we okay? And we know that with the row operation, we are going to combine the matrix A with the identity matrix to produce a certain identity matrix and the inverse of matrix A this way. Are we okay? So first, let's try and combine the matrix. So matrix A, that is 1, 2, negative 1, negative 2, 0, 1, 1, negative 1, and 0. Combined with the identity matrix, which is 1, 0, 0, 0, 1, 0, 1, or 0, 0, 1, this way. And we are to perform row operations in order to turn this matrix into the identity matrix. So first, I can see I have 1 here, which is perfect. So this is okay for me. And I have to get 1 on this side and here also to be 1. Another element should turn to 0. Are we okay? So first, I want to turn this negative 2 into a 0. What do I do? So I will want to turn it into a 0. If I want to turn this negative 2 into 0, I can say I multiply this one by 2, then add it to this, because this will be positive 2 plus negative 2, and this will turn into what? A 0. Is that okay? And that should happen on row 2. So we are going to perform on row 2, 2 multiplying row 1 plus row 2. And this is going to give us this. So meaning row 1 is going to be the same 1, 2, negative 1, 1, 0, 0. Row 3 will be the same 1, negative 1, 0, 0, 0, 1. But row 2 is going to change. So 2 by 1 plus negative 2, and that is going to be 0. 2 by 2, which is 4, plus 0, that is going to be positive 4. 2 by negative 1, negative 2, plus 1, and that is going to give us negative 1. So 2 by 1 plus 0, 2. 2 by 0 by 1. So that is going to give us what? 1. 2 by 0 plus 0, that will be 0 this way. Alright, so this is what we've obtained. And I would like to change this one also to a 0. So I can add row 1 and row 3 such that, or I can subtract row 3 from row 1, which will make this part turn to 0. Is that true? And that is going to happen on row 3. So meaning on row 3, I'm going to have row 1 minus row 3. Meaning row 1 is going to remain the same. 1, 2, negative 1, 1, 0, 0. Row 2 is going to be the same. 0, 4, negative 1, 2, 1, 0. But row 3 is going to change. So that will be 1 minus 1, that is going to be 0. 4 minus 1. Are we okay? So this is going to be on row 3. We are saying row 1. We are considering row 1 instead. So that is going to be 2. This 2 minus 1. And that is going to give us positive 3. row 1, which is negative 1 minus 0, and that is going to give us negative 1. So here 1 minus 0, that is 1. 0 minus 0, 0. That's 0 minus negative or 1, which is going to give us negative 1, like this. So this is cool. Are you okay? So we now have this. We still need to get 1 somewhere. Are we okay? So this 4, I want to turn this 4 to a 1, such that all the principal diagonal will have 1. This is 4, this is 3. I can say root 2 minus root 3, such that it will be 4 minus this 3 to give me a 1. So that's simple, and that is going to happen on root 2. So on row 2, I'm going to say row 2 minus row 3. So meaning row 1 is the same, which is 1, 2, negative 1, 1, 0, 0. Row 3 is going to be the same, 0, positive 3, and negative 1, 1, 0, negative 1. Now, row 2 minus row 3, 0 minus 0, 0. 4 minus 3, that is going to be 1. And we are going to have negative 1 minus 1. That is going to give us also 0. Are we okay? So now we have row 2, which is 2 minus 1. This is going to be 1. 1 minus 0, 1. 0 minus 1. That is also going to give us positive 1. So we now have this. Are we good? So luckily, we are turning this side into the identity gradually. We have to also do something in order to turn someone into a 0. So I want to turn this 2 to a 0. What do I have to do? I can say this row, which is the row 1, minus 2 times this, and this will turn this towards 0. That operation will happen on row 1. So on row 1, I'm going to say row 1 minus 2 times row 2. There's no specific formula that you have to follow. You have to do this on your own. Check the matrix and how you will turn it into a 0 or a 1. Are we okay? Alright, so here it's happening on row 1, meaning row 2 is going to remain the same. That is 0, 1, 0, 1, 1, 1. Row 3 is the same, 0, 3, negative 1, 1, 0, negative 1. But row 1 is going to change. Now, row 1, which is 1 minus 2 times row 2, which is still 1. So row 1, 2 minus 2 by 1, that is going to give us 0. Negative 1 minus 2 by 0, still negative 1. Now, row 1, 1 minus 2 times this, and that is going to be negative 1. 0 minus 2 times this, negative 2. 0 minus 2 times this, negative 2. This way. Are we okay? So we now have this matrix. So we also have to change this negative 1 to 0, this 3 to 0, and make this negative 1 also as what? Positive 1. So now I'm thinking of making this positive 3 go to 0. And luckily for me, this is 1. So when I multiply this by 3 and subtract it from that, I'm going to get here to be 0. So let's do that and see our results. So I'm going to perform the operation on row 3. So on row 3, I'm going to say 3 times row 2 minus the row 3. And this is going to give me something like this. So row 1 will remain the same. 1, 0, negative 1 by -1, -2, -2. Row 2, the same, 0, 1, 0. We have 1, 1, 1. Row 3, now it is going to be 3 times row 2. So 3 times 0 minus row 3, 0, still 0. 3 times 1, which is 3, minus 3, that is going to be 0. Now 3 times 0 minus 1, and that is going to be positive 1. 3 times 1, which is 3, minus 1, and that is going to be 2. 3 times this, which is 3 minus 0, that is going to be 3. 3 times 1, 3 minus 1, that is going to be 4, this way. So this is what I have. I have to turn this negative to a 0 so that I will achieve the identity here. So meaning I have -1 here, I have +1. I can just add the rows and I'll get 0 here. So on row 1, I'm going to say row 1 plus row 3. So meaning row 3 is going to be the same, 0, 0, 1, 2, 3, 4. Row 2 is going to be the same, 0, 1, 0, 1, 1, 1. On row 1, which is going to be row 1 plus row 3, so 1 plus 0, 1. 0 plus 0, that is going to be 0. -1 plus 1, that is going to be 0. So -1 plus 2, that is going to be +1. -2 plus 3, that is also going to be +1. -2 plus 4, that is going to be +2. So now when you check, I've converted this matrix into the identity matrix. So whatever is here becomes the inverse of the matrix. Therefore, A inverse is going to be 1, 1, 2, 1, 1, 1, 2, 3, 4. So this is the inverse of the matrix A after performing the row operations. You have to be careful when you are performing the row operation, because if you don't get it strategically, you perform a lot of operations before you may end up getting that. Are we okay? So if you want to check if it is right, then your A matrix multiplying by its inverse is going to give us the identity matrix again. Are we okay? So thank you for watching this. You can try out certain examples and you will be fine. Please subscribe to the channel, comment and share the video.